Before we go into this next set of delta maths, um, we need some background information. I want you to kind of look at these. Look at these angles in quadrant number 1. So here's a basic fact. This length is 1. That's why it's called the unit circle. This length is also 1. The radius of this circle is 1. But I deliberately made an angle here so that this length, which is kind of an altitude from the hypotenuse to here, is exactly 1/2. This is 1/2, okay? This side of this triangle is 1. And question is, what's the length of this side? Question mark. Well, let's do a little Pythagorean theorem. This is x squared plus 1/2 squared equals 1 squared, which luckily is just 1. So x squared plus, and I'm going to square the top and the bottom, plus 1/4 is 1, x squared equals 3/4, right? Because I subtracted this. That means when I take the square root of both sides, we're looking at x equals square root of 3 over 2, because you took the square root of the top and the square root of the bottom. So this side here is square root 3 over 2. Guess what this angle is? This is a very important fact. This angle is exactly 30 degrees. Okay, it's a strange coincidence that when you go up to such that this length is half the length of, well, this length, which is also this length, but this doesn't count because the triangle stops right there. But it's the same as this length. You get this interesting kind of length, okay? Now you want to know something freaky? Not freaky. What is the sine of 30? The sine of 30, if you put it into calculator, is 0.5. It's exactly 1/2. Okay, well, that makes sense, right? Because it's the opposite over 1. Anything over 1 is just itself. And what's the cosine of 30 degrees? It's this, right? Because this is the length of this side over the hypotenuse, which is 1, so you don't bother putting it over 1. Divided by 1 is just the same. And this point on the xy axis is exactly this far from the y-axis. So the x of that coordinate point is this, and the y of that coordinate point is 1/2. So this dot represents in its x the cosine of the angle that's formed here to get there, and the sine of the angle that was formed to get to here on the unit circle. Okay? This is kind of the stage at which all this comes together. Let's look at this angle right here, that angle. This is exactly a 45-degree angle from here, okay? And so we know this length is 1. And let's drop that altitude, I think they call that the altitude, down to here. And question, what's this length And by the way, what's that length? Hey, guess what? These two lengths will be the same because guess what? That angle is also 45. These are complementary, aren't they? Complementary. They got to equal 90. That's why 30, 60, 90. The other one angle was 30, the other was 60. They're complementary. So these two are going to be the same length. What are they? Let me cut to the chase. I'm not even going to do the Pythagorean. It's this. Root 2 over 2. Yes, put this in the calculator. It's going to be a bunch of decimals that go on forever. But if you're going to be super accurate, not cut off those decimals, this is the value. Okay? So same thing. Sine of 45. Sine of 45 is this length over 1. So you can ignore that 1. It's that. The cosine of 45 is adjacent over hypotenuse. Who cares about the hypotenuse? It's 1. Okay? And these values are linked with the coordinate point that is on the unit circle right there at the 45-degree angle. Root 2 over 2, comma, root 2 over 2. All right? And they're all positive because we're in quadrant 1. Last. I want you to look at this angle right here. Okay, that's formed from the terminal side. This angle is 60, which makes that angle 30, but we don't care about this angle because this is not a reference angle. Remember, reference angles are formed from this side to the x-axis. X-axis. But it is that same triangle you saw at the top, flipped. So take a look at this side. That's always 1. The hypotenuse in all these cases is 1. And do you remember? This side is half the length of this side. This is half the length. This side is half, which makes this side, since it's just like the first one flipped on its side, root 3 over 2. Okay. When you do the delta math, you'll see delta math, I think, says memorize these values. But you at least need to know where they come from. Yes, you do have to memorize them, but know where they come from. These 30, 45, 60, and by the way, 0, 90. These are all common angles. Common angles. These have a special word. I think they're called compass because they're kind of like the 90, 180, 270, like a compass. And the sine and cosine values of these common angles are limited to 1/2 root 2 over 2. Root 2 over 2 is for your 45s. 1/2 and root 3 over 2. These are for your 30s and 60s. Okay? And so let's see what we're talking about when we look at the entire unit circle. These numbers will have a dual identity as being the x and y coordinates of these points that I'm pointing out, as well as the sine and cosine value of the angles that are formed starting from here and rotating clockwise, okay? So first stop. I'm not even going to draw those. Whoop, okay. Root 3 over 2, 1/2. In the parentheses, I always say cosine first and sine second because cosine is associated with x, sine is associated with y. Next stop. Root 2 over 2, root 2 over 2. This stop right here. It's flipped. The x is 1/2 and the y is root 3 over 2. Let's also not forget these points. The x is 1, the y is 0, right? Because we've already told you this length is 1 and it's sitting right on the x-axis. Right here, the x is 1, the y is 0. But you know what that means? That means sine of 90 degrees is 1. There it is. Cosine of 90 degrees is 0. Put that in the calculator and it'll prove me right. Over here is where you're using your knowledge of the signs of the trig functions into different quadrants. Yes, the x here is 1/2 because it's short. And this is long. The height here is long, right? And so that's root 3 over 2, but I am missing an important thing, which is it's negative 1/2, right? Negative 1/2, positive root 3 over 2. That point right there is negative root 2 over 2, positive root 2 over 2. This is the cosine. This is the sine, okay? I'm going to keep going. Okay, look at this. Cosine and sine, both negative. Y is negative, x is negative. Look over here. Cosine is positive, sine is negative because it's below the x-axis. This one, cosine is positive, sine, negative. All right? Okay, so let's go back to delta math. Based on our knowledge of the unit circle, let's go over to 315. Notice how it clicks on the common angles. Okay, 270. 270, I think we stop here because 270 plus 45. 270, another 45, that gets you to 315. And 45 is halfway between here and here. So I think we're going to stop there. And they want to know the cosine, which is this length here, because cosine is x, and that length of this 45 triangle, this length, they're both the same, this, and it's this, and it's positive. Root 2 over 2, positive. Tan of negative 45. We're going in this direction. So tan is sine over cosine. So sine is this length here, negative root 2 over 2. But guess what? Cosine is this length here, and it's exactly the same. It so happens the sine is negative, cosine is positive, but when you have same over same, negative over positive, you're going to have a negative 1. Isn't that right? If these two things are exactly the same, but they have different signs, you're going to have negative 1. So the tan of negative 45, of course you can put in the calculator, but you're not going to. You're going to do it based on your knowledge. Let's see what delta math tells you. Go clockwise. We did go clockwise this way, and we stopped here, which is halfway between here and here. That means these two sides are the same. Y value over x value. It's negative down here. We talked about that before. And so reference angle, if we were in this first quadrant, and you're there to compare sides in a normal way, it would be 1. But because you're down here, it's -1. Sine of 90 degrees. Let's take this over to 90 degrees. Okay, so guess what? Sine is the y value, and the y value is 1. Y, literally, y is 1 of that point. Tan of -90. Okay, well, let's go the opposite direction here. And now let's do the definition of tan is sine over cosine, which is really y over x. Well, what's the y of this point? Y here is -1, but the x over here is 0, isn't it? Uh-oh, what do we call that? We call that undefined. Okay, so watch for tan and cotan. That can happen, where your denominator is 0. And the rest of it is really just doing it without that little drawing tool or the circle tool. So you've got to go in and you've got to rotate yourself. Just before 180. I'm 30 degrees shy of 180. So this is my 150. So because I have a 30, 60, 90 triangle, this is 30 degrees in here. That's 30 degrees. Cos of 150, we're talking about this length right here. And for a 30, 60, 90, that's the longer of the two. And the longer of the two is √3/2. But I'm about to catch myself. Okay. However, where are we? We're in quadrant 2. And guess what? Cosine is negative out here because it's x. Better throw a negative onto my answer. Last one for this set. Exact value of tan, 210. Sometimes I make a circle. 210, 180 is here. I got to go 30 degrees more, so that lands me here. This is another 30, 60, 90. I mean, there are only two types of triangles, 30, 60, 90, and then 45, 45, 90. My 30 degrees is my reference angle here. Okay, so what do they want to know? Tan. Tan doesn't compare the hypotenuse. Hypotenuse is left alone. It is what you call opposite over adjacent, or in our new parlance, it's y over x of this point. Okay, so the y, it's a short length, and I'm going to use a sine when I fix the y on top, and the x is also, it's the longer of the two, which is, this is the longer of the two. This is x. And notice I applied a sine on this one too. This is to remind me that when I calculate this, my answer is going to be positive. Tan's going to be positive in quadrant 3, okay? Because negative over negative makes positive. Well, so tan is always a little bit of a pain. You got to do 1/2 divided by this, which is kind of a keep, change, flip operation. Keep, change to multiply, flip, I flipped it, I can cancel these out. Okay, this is not going to be good enough for delta math. Simplest form means you've got to abide by the rules of not having radical, an irrational number in your denominator. So you do one of these moves and you get this, and it's positive. √3/3. And it's positive. Tan 210 is positive. Find the reference angle as we did. And so this is kind of a little helpful map of the common ratios involved in sine, cosine, and tan. Okay, this is the answer we just came up with in a 45-45, in a 45-degree angle. For your reference angle, it would be this. And then when you're comparing the large side of a 30, 60, 90, and when I say large, I mean this, and you're dividing it by the short one, you're going to get something that's more than 1, and that's more than 1. So let's do a keep, change, flip. Keep, change, flip, multiply, cancel out. This is what you get. That's what they're referring to right there.